Most people today carry a device in their pocket that would have seemed like science fiction just a few decades ago. A smartphone can connect to satellites, process billions of calculations per second, store years of memories, access almost the entirety of human knowledge, and communicate instantly with anyone on the planet. Laptops and tablets can create music, design buildings, edit films, run businesses, and simulate entire worlds. Yet despite how deeply these devices are woven into daily life, most tech users do not really understand the devices they rely on. They know how to tap, swipe, click, and scroll, but the deeper workings remain invisible, mysterious, and often misunderstood. This lack of understanding is not a personal failure of users. It is the result of how modern technology is designed, marketed, and integrated into society. To understand why this gap exists, it helps to look at how people interact with technology in the first place. Most users approach devices as tools, not systems. When someone buys a phone, they are not thinking about processors, operating systems, memory management, or network protocols. They are thinking about taking photos, chatting with friends, watching videos, or managing work. The device is judged by how well it delivers these outcomes, not by how transparent its inner workings are. Over time, this creates a relationship where users focus only on surface-level interactions. As long as the tool works, there is little motivation to look deeper. The complexity underneath becomes irrelevant to everyday use. Modern technology actively encourages this surface-level relationship. Devices are designed to hide complexity as much as possible. Interfaces are simplified, options are abstracted, and processes are automated. When you tap an icon, you do not see the thousands of processes that start, pause, or stop in the background. When you send a message, you do not see how it is encrypted, routed through servers, and delivered across networks. When you install an app, you are not shown how permissions interact with system resources. This design philosophy is intentional. Companies want devices to feel intuitive and effortless, even for users with no technical background. While this makes technology more accessible, it also removes opportunities for learning and understanding. Another reason most tech users don't understand their devices is that technology evolves faster than education systems can keep up. In many schools, digital literacy is still treated as basic computer use rather than deep understanding. Students learn how to use word processors, presentation software, and browsers, but rarely learn how operating systems work, how data is stored, or how networks function. Even when programming is introduced, it is often taught in isolation, without connecting it to the devices students use every day. As a result, people graduate knowing how to use technology but not how it actually works. They become consumers of tech rather than informed participants in the digital world. Marketing also plays a major role in shaping user understanding. Tech companies sell experiences, not explanations. Advertisements focus on sleek design, emotional moments, speed, and convenience. They show people capturing memories, staying connected, or being productive, but they rarely explain what makes these experiences possible. Technical details are either oversimplified or hidden behind buzzwords. Terms like AI-powered, cloud-based, or next-generation processors sound impressive, but often mean very little to the average user. Over time, people become comfortable with vague explanations and stop asking deeper questions. There is also a psychological factor at play. Many people believe that technology is too complex to understand unless you are an expert. This belief creates a mental barrier. When something goes wrong with a device, users often feel helpless. They assume the problem is beyond their understanding and immediately look for external help. This mindset discourages curiosity and experimentation. Instead of exploring settings, reading documentation, or trying to understand errors, users avoid engagement and hope the problem resolves itself. Over time, this reinforces the idea that technology is magical and unknowable. The language used in technology further widens the gap between users and understanding. Technical terminology can be intimidating and confusing. Words like kernel, firmware, cache, protocol, and virtualization are rarely explained in simple terms. When explanations are available, they are often written for other professionals rather than everyday users. This creates a situation where people feel excluded from understanding their own devices. They may encounter terms like RAM or CPU, but only know them as abstract concepts associated with speed or performance, not as components with specific roles and limitations. Another key reason is that most users do not need deep understanding to achieve their goals. A person can use social media, stream content, shop online, and work remotely without knowing how data packets travel across the internet. Convenience reduces the incentive to learn. In earlier eras, using technology often required more involvement. Early computer users had to understand command lines, file systems, and hardware limitations. Today, much of that complexity is handled automatically. While this is a major advancement, it also means fewer learning moments for users. The rise of closed ecosystems has also contributed to this lack of understanding. Many modern devices are designed to work best within tightly controlled environments. Operating systems limit user access to system-level features. Hardware is sealed, making repairs and upgrades difficult or impossible. Software is distributed through curated app stores with strict rules. While this improves security and stability, it also prevents users from seeing how things work under the hood. When users cannot open, modify, or experiment with their devices, their understanding remains shallow. Fear is another powerful factor. Many users are afraid of breaking their devices. They worry that changing settings, installing the wrong app, or clicking the wrong button could cause permanent damage. This fear is not entirely unfounded, as mistakes can sometimes lead to data loss or system issues. However, it discourages exploration. Instead of learning through trial and error, users stick to familiar patterns and avoid anything that looks technical. Over time, their interaction with technology becomes narrow and repetitive. The way technology handles errors also affects understanding. Error messages are often vague, technical, or unhelpful. Instead of explaining what went wrong and why, they display cryptic codes or generic warnings. This leaves users confused and frustrated. When problems are resolved through automatic updates or remote fixes, users never learn what happened. The device becomes a black box that sometimes works and sometimes doesn't, without clear reasons. Social influence also shapes how people relate to technology. In many cultures, being bad with tech is normalized. People joke about not understanding computers or phones, and this attitude is socially accepted. Unlike other skills, technological understanding is often seen as optional. If something goes wrong, there is usually someone else who can fix it. This reduces the pressure to learn and reinforces dependency on others. The pace of technological change adds another layer of difficulty. Even users who try to understand their devices may feel overwhelmed by constant updates, new features, and changing interfaces. Just as someone becomes comfortable with a system, it changes. Menus are redesigned, features are renamed, and workflows are altered. This constant change makes it hard to build lasting mental models of how devices work. Instead of deep understanding, users develop adaptive habits that focus on getting things done quickly. Another important aspect is the invisible nature of digital processes. Unlike mechanical tools, where movement and cause and effect are visible, digital systems operate in abstract spaces. Data moves silently. Calculations happen instantly. There are no obvious physical cues to help users understand what is happening. This abstraction makes it harder to form intuitive understanding. People can see how a car engine works or how a lever moves, but they cannot see how software executes instructions or how networks route data. The convenience of automation further reduces user involvement. Devices now make decisions on behalf of users. Algorithms curate content, manage resources, optimize performance, and predict behavior. While this improves efficiency, it also distances users from the underlying logic. People may not know why certain notifications appear, why battery life changes, or why performance slows down. These decisions are made by systems that users neither see nor understand. Security and privacy are areas where lack of understanding becomes particularly problematic. Many users do not fully understand how their data is collected, stored, and shared. They agree to terms and permissions without reading them. They may not understand the implications of cloud storage, tracking, or data breaches. This is not because they don't care, but because the systems involved are complex and poorly explained. Without clear understanding, users cannot make fully informed decisions about their digital lives. Economic factors also play a role. Technology companies benefit from users who rely on them without questioning how things work. When users do not understand their devices, they are more likely to accept limitations, upgrades, and replacements without resistance. Planned obsolescence, subscription models, and locked-down ecosystems are easier to maintain when users lack technical awareness. This creates little incentive for companies to educate users beyond what is necessary for basic use. Another reason is the specialization of knowledge in modern society. Technology has become a field of experts. Engineers, developers, and designers work on highly specific aspects of systems. Expecting every user to understand all of this may seem unrealistic. As a result, understanding is outsourced to professionals. While specialization is necessary, it also means that general users are increasingly disconnected from the systems they depend on. Cultural narratives around technology also contribute to misunderstanding. Technology is often portrayed as either magical or dangerous. In movies and media, devices and systems are shown as mysterious forces beyond human control. This reinforces the idea that understanding is reserved for geniuses or hackers. Everyday users see themselves as outsiders, further reducing curiosity and engagement. Despite all this, it is important to recognize that not understanding technology deeply is not inherently bad. The goal of technology is to serve human needs, not to turn everyone into an engineer. However, the problem arises when lack of understanding leads to dependency, vulnerability, and loss of control. When users do not understand their devices, they are less able to troubleshoot issues, protect their data, or make informed choices. There is also a generational misconception at play. Younger users are often assumed to be more tech-savvy because they grew up with devices. While they may be comfortable using apps and platforms, this does not necessarily mean they understand how the technology works. Familiarity with interfaces does not equal understanding of systems. In some cases, older users who experienced earlier, less abstracted technology may have deeper conceptual understanding. Another subtle factor is time and cognitive load. Modern life is busy, and learning how technology works requires time and mental effort. Many people prioritize immediate tasks over long-term understanding. When a device works well enough, learning more about it feels like unnecessary effort. This is especially true when explanations are not easily accessible or engaging. The design of help systems and documentation also affects understanding. Manuals are often long, technical, and rarely read. Online help articles may assume prior knowledge or focus on step-by-step fixes rather than conceptual explanations. Video tutorials often show what to click without explaining why. This helps users solve immediate problems but does not build deeper understanding. Over time, all these factors combine to create a gap between users and their devices. People become skilled at using technology without understanding it. They know which buttons to press but not what happens next. They trust systems they cannot explain and depend on tools they do not fully control. This gap is not always visible, but it becomes apparent when something goes wrong or when users are asked to make important decisions about technology. Understanding this issue is the first step toward addressing it. Improving user understanding does not mean overwhelming people with technical details. It means designing technology that is transparent, educational, and empowering. It means teaching digital literacy as more than just usage. It means encouraging curiosity and reducing fear. It also means acknowledging that technology shapes society and understanding it as part of being an informed citizen. In the end, most tech users don't really understand their devices because they were never encouraged, required, or enabled to do so. The systems are complex, the interfaces are simplified, the explanations are lacking, and the culture discourages deep engagement. Technology has become so seamless that it fades into the background of daily life. While this is a testament to its success, it also highlights a growing disconnect. Bridging this gap does not require everyone to become an expert, but it does require rethinking how we design, teach, and talk about the technology that defines the modern world.